So we could talk about how blood moves through our circulatory system, and it's quite impressive if you think about if you were to remove the circulatory system and think about how extensive it is and all of this extensive branching that is pumped by this heart, right? So how does the blood travel? How does it actually keep its pressure, for example? How does it keep moving through the blood vessels? So we need to talk a little bit about physiology. So that's the how, right? Instead of just the anatomy. When we talk about the physiology, we can talk about blood flow. And this really comes down to kind of some physics, right? So like the flow of a fluid through a tube. So you can think about blood flow in that way. So it is measured in milliliters per minute. That is its unit. And so we talked about cardiac output. And so the blood flowing through the circulatory system really has to do with cardiac output, right? How much blood? And what was that? That was like cardiac output equaled about 5,250 milliliters per minute, or 5.25 liters. So if you think about like a couple liters of Coke, that's a lot of fluid that is moving in our blood vessels. Generally, blood flow is relatively constant. It doesn't like start and stop with the beating of the heart. So when the ventricles contract, it forces blood out, but the blood doesn't like just stop. It stays moving. It stays flowing continuously through the blood system. And one of the reasons for that is that elastic arteries keep it moving. So as they expand, then they come back in and then they propel it forward. And so the blood keeps moving smoothly through the body, okay? We could also talk about blood pressure. So blood pressure is measured as millimeters of mercury, the same thing that our atmospheric pressure is measured at. So this is millimeters of mercury. So mercury, its elemental symbol is Hg. So that's my unit of measure. And when we look at blood pressure, we're generally talking about arterial blood pressure. So we might be measuring it in my brachial artery, for example, and we have like 140 over 90. What is that? That is 140 millimeters of mercury over 90 millimeters of mercury. This is what is referred to as the systolic pressure. This is what is referred to as the diastolic pressure. This has to do with the alternating contraction and relaxation of our ventricles. So systolic pressure would be when the ventricles contract. So ventricular systole. So that is when systole is when they contract in the cardiac cycle. Diastolic pressure is ventricular diastole. Right. Now, when we look at pressure is actually what propels the blood forward. So if pressure drops to 0, then your blood is going to stop, which is very, very bad, right? So that pressure is what keeps the blood moving. So blood always moves from a higher to a lower pressure. And this is the same thing we would see in a non-living system, right? So if we're thinking about pipes in a house, right? This is the same thing, is that is the pressure that is actually allowing things to move. Okay. Now we also have in the physiology resistance to flow. So we call this resistance, and it could be called peripheral resistance, because it is not resistance in the heart in this particular instance. So it's resistance in the periphery of your cardiovascular system, which would be your arteries, your capillaries, and your veins. So when we talk about resistance, this is the amount of friction that the blood is exposed to. So the amount of friction preventing the blood from moving. Now, even when you think about the flow of water in a river, you'll notice that the fastest channel is usually right through the middle, right? So when it is up against the bank, the water slows down because of resistance to flow. And in that case, it's just gravity, right? Pulling the water towards the ocean. So we can talk about that in terms of resistance, but we'll talk about what factors, other factors, influence the resistance to blood flow.